Hi, everybody. I'm here in Newby with Emesent. Not sure if you're familiar with us or not, but we are a SLAM-based LiDAR manufacturer based out of Brisbane, Australia. I've been in business for about 5 years now. Our founder and co-founders, they were involved in drone autonomy at CSIRO, which is kind of the DARPA think tank of Australia. They came up with Wi-Fi, a bunch of other technologies. They've worked on drone autonomy for about 15 years there. And the SLAM LiDAR technology, the algorithm was developed by CSIRO. So when they saw this SLAM technology, they coupled it with the autonomy, and that's how they came up with Emesent. So this is our Emesent Hovermap. It is a SLAM-based LiDAR, simultaneous localization and mapping, specialized for GPS-denied environments. It works great underground, limited GPS, within cities, anywhere you're just going to have trouble gathering and maintaining a GPS signal. We're going to work really well there. What's unique about us is we can be deployed in several different manners. So on spot, handheld, put it in a cage, drop it down a tunnel or cave, on a drone, being driven in a backpack, a lot of different deployment options. But the really unique thing about us is that we do have full autonomy on a drone. So if you need to get into an area that is completely restricted, let's say a stope, something like that, you can fly the Hovermap over it, set a waypoint, push a button, it takes off, does its thing, gets to the waypoint, and comes back. You'll lose full connectivity to the Hovermap and the drone, and it comes back every time automatically. It's being used around the world in mines, a lot of different AEC applications, anywhere where there's danger or inaccessible areas that need to get mapped, this will take care of it. So what we do is, with our sensors, we have the ability to give a full 360-degree view from the Hovermap with a rotating puck. So you get highly reliable and very dense point clouds. Along with that, because it is LiDAR, there's no shadows, you don't need light, you can go into a completely dark area and go out there and capture everything you guys need. And lastly, with that data, you can output into several data set or point cloud file formats that will be easily ingestible into pretty much any third-party software you're going to be using to do the analytics. Again, there are so many areas that you guys are working with that have limited or no GPS signal. That it's going to make scanning them a little more difficult with some of the traditional methods. And let me be clear, this is not a replacement to total stations, a lot of the different traditional methods of capturing data. This is another tool in the toolbox that you guys can use to quickly, effectively, and safely go out there and collect data that is usable almost instantly. We have two different products. Both of them, when you purchase it, they come with everything you need to begin hand scanning out of the box. So we have two versions of it, the ST and the STX. But again, when you buy it, you can immediately go out there and start doing hand scanning. Hovermap ST uses the Velodyne VLP16 pod, which you guys are probably pretty familiar with, fairly standard in the industry. That's 300,000 points per second with dual return at 600,000 points. The Hovermaps both have a 500 gig hard drive on board, and we utilize Wi-Fi to communicate with the tablet. If you're flying it, or even if you're walking with it, you can in real time.
Okay, Brian says we're good.
Yes.
Okay, sorry about that.
All right, so I spoke about the versatility of the Hovermap. Unlike any other solution out there, we can be deployed in so many different methods. On spot, walk around with it, put it on a backpack, in a cage, deployed on a drone, and also driven around. We also have a new product coming out, which is an LHD mount. for the boggers or knockers, whatever you guys want to call them here in the States, call them boggers in Australia. But for this, you can put it on a big machine, continually run it in and out. You can and monitor the tunnels for overbreak, underbreak, see how much volume is being pulled out every day, that type of. Yeah. There we go. Additionally, we have long range radio for it if you're doing above ground applications or even below, and you need that in at a distance to it. Long range radio outdoors, line of sight will be about 1.5 distance. If you're skating around a bridge, underneath the bridge, about 350 meters. And then with the underground, even beyond visual line of sight, we get about 150 meters of Wi-Fi range. So we have essentially 4 levels of autonomy. So the first one is core. Now, core was recently launched by us as a way to get the price of the Hovermap down to compete with a lot of the new Chinese manufacturers that are coming out. So with core, it includes all the same mapping features as the rest of the Hovermap autonomy levels. So you can do all of the merging in Aura, which is our software. Where we do the processing. You can do noise reduction, filtering, moving object removal. And what you don't get with core is the colorization, GCP, RTK, and 360 camera. So you won't get those features. There are additional add-ons if you want to do that. But if all you're doing is utilizing the point cloud, that's the ideal for you. You can still mount to a drone, but it's just going to be payload at that point. With mapping, essentially the same score, except you do get colorization, GCP, RTK, and 360 camera availability to do processing. When we get into autonomy level 1, that's when it starts to get fun. This is what we call pilot assist mode. So essentially what the Hovermap does when you mount it to a drone is it creates what we call a batch, a virtual elliptical shield, where the Hovermap is utilizing the point cloud that's being generated real time, and it can see objects in that point cloud. It will physically not allow the drone to fly into it. So I've seen demonstrations where we're in the forest, we have the slam or the batch turned on, and you fly the drone straight for tree branches, and it just stops. It won't let you hit anything. You can also see exactly what's going on the tablet, and you can navigate using the tablet or using DJI mode. We work with the M300, M350, and for those of you who cannot use Chinese-made drones, we have the new Free-Fly Astro that we're going to be launching at Newby. And with that, we'll do the exact same thing. Full autonomy is where it gets just epic. So with full autonomy, you are basically hands off the drone. You pick the drone up to hover, you set a waypoint, you can set multiple waypoints, even if you don't know where it needs to go. So again, scopes exactly. You get to the barrier, you need to go out, you need to go down or up, and you're not really sure what's out there. So you just go out, hover where you need to, and you set a waypoint up. You don't even know what's out there. Just set a vertical waypoint, push tap fly, automatically takes off. You're going to lose connectivity to it. You're going to pucker real hard when it goes away because you can't even hear it, can't see it, lose connectivity on the tablet. 3 minutes later, it comes back a full scan. It also does have some safety features. So the battery gets to a certain point. The Hovermap has AI built in. It determines I need to come back at this point. I don't have enough battery to make it. I don't. Also, if you get into a real dusty situation, it has a dust lock feature where it will essentially just stop there, utilize the points that it can pick up and come back out. And also, if there's an error on the drone, it recognizes that, communicates with it, and then automatically comes back. Word. All right, so this is what autonomy looks like now. So right here, we're utilizing the tablet, and essentially we just hit tap to fly. I go see around this little hump. That's where we started off. We had no idea what was on this tunnel, so all we did is set a waypoint off in the distance. Started up here, set the waypoint there, push the button, starts ignition on its own. Now, somewhere along this point, we probably lost connectivity to the Hovermap drone. It's still collecting data, even though you're not seeing it off the tablet. When it does get to the point where it comes back, all that data will populate on the tablet, so you'll see exactly what was scanned in that entire area. You'll notice here, when it gets to the end of this tunnel, it can't go any further. So the waypoint is further out there, but it has AI built into it that if it can get to the waypoint, find those couple turns, comes back, it will try to get to that waypoint even if possible. So in a lot of cases, it will go down different tunnels, shafts, try to get to that waypoint, and if it can't, kind of gives someone comes home. The workflow, super easy, very simple, quick and effective. So first off, you start the hover map, it takes about 60 seconds to get it set up. All you do, pick it up, plug it in the battery, push a button on the back, takes about 60 seconds, it starts turning in your scan. You don't need to hold it still, you don't need to have it completely stationary, with nobody moving around it. You can be waving it around like this when we started out, makes no difference. When it starts up, you're scanning. Go out there, do the scan, whether it's a flight, on a vehicle, walking with it. When you're done, push the button on the back, take a USB drive, put it in the back of it. It automatically offloads most recent data, most recent scans. So if you go out there today and you do 5 scans, get back to the office, sit in the truck, put the thumb drive in, offload all 5 of those. And you can start processing. The 500 gig hard drive comes in handy at this point because all of the scans that you do offload go to a subfolder and they're saved there until you physically go delete them. Because we all know people with thumb drives, they get crowded, they get crushed. So you always have that data until you go in there and delete it, just in case you need it for later. We do everything locally, nothing is done over the cloud, so we're not going to charge you to do processing on amounts of data that you use. So all you do is you plug that thumb drive into your laptop or workstation. Simply drag and drop those files over to our software, take cues from 1 through 5, and just start working. So if you have a 5-minute scan, it takes anywhere between 10 minutes to process that data. And it'll output an LES, LAZ, PLY, E57. So most of the common files that you guys are going to be using is the software that you guys are doing the third-party work with. This is what the software looks like, really straightforward, simple. Again, there's a lot of filtering options in here. You can degrade the point cloud, make it smaller if you need to. And you can set different options in here as far as filtering and object removal. Also in here, you can merge multiple scans. So let's say you're doing a building inside, outside, you got 3 stories, you can do 2 scans inside, fly the outside, process all 3 scans in the software, align them, merge them, and you're done. We also have ground control. We automatically ingest ground control points. So if you have control these up at the top of those.
Okay.
So the GCPs, very easy to use. It automatically picks them up. All you do is you put the file in with the known points, automatically registers all of those points. Okay. The other thing GCPs do is, if you're familiar with SLAM technology, you're familiar with drift. So over long segments or areas that don't have a lot of features, sometimes SLAM can kind of wobble a little bit and drift. GCPs do a really good job of tightening those up with known points and pulling everything in to be much more accurate. We also have colorization. We do colorization in two different ways. I'll get to the second one after this. The first one is a simple GoPro camera that's mounted and calibrated to the Hovermap itself. So it, when you go through the processing, it automatically pulls that colorization in. It aligns the color to the points and actually colorizes each of those individual points using the camera. When you're colorizing, it does add to the process time because it's a video file that it's ingesting, but you know, for the work that it does, it's actually pretty good. It's not photogrammetry, we know that, but we're working on it. We also have RTK and releasing what we call car TK, which you can probably figure out is going to go on a vehicle or handheld. But the M300, M350 do have RTK capabilities where we can pull in the geo coordinates, and then the car TK, which is really cool, mounted to a vehicle, carry it on the backpack, whatever it may be, drive around for 20 minutes and it'll geolocate the entire scan. So you can do larger urban areas using the car TK, geolocate it, and even use the 360 camera while doing it. So 360 imaging, not real happy with the setup we have right now, but we're working on a different one. But essentially, at this point, what we're doing is we're pulling in the 360 images, and we have a point cloud on one side, 360 images on the other. When you rotate one, you can see both exactly where they're looking. You can zoom in, you can do kind of the Google Maps or the walking scan and rotate from each of those points. We also have Spot autonomy in our beta testing and early adopter program right now. Anybody use Spot? Expensive toy. But you know, just give you an idea of some of the cool stuff we're working on. Autonomy is our bread and butter, and we're moving forward with Spot. We've got a lot of other stuff on the roadmap right now to continue different levels of autonomy with different type of vehicles. So the benefits of Hovermap, really it is time savings. Rather than sending a team of 2-3 people out there with traditional methods, you can get the exact same data utilizing the Hovermap, walk around with a handheld, get the data quick, process it quickly while you're on site. I don't know how many times I've heard where a team gets sent out to go do some work, to get back to the office, and like, oh crap, we didn't capture everything we needed. So while you're on site, you can easily process it, get the data right there, understand what you have, and know whether or not you got everything you needed. The ROI kind of speaks for itself. Like he was saying earlier, time is money. And we can do something in 10 minutes that usually takes 3 hours. That's a huge cost benefit. Low operating costs, you just pay for the Hovermap. We do have subscription model. We also have that core, which is a perpetual license that you never have to pay for again. So I'll run through a few of the common use cases. I may skip through some of these slides a little bit fast because I know that I'm getting hungry. So for AEC, industrial infrastructure, anything indoors where you have large assets, you need to scan them. Let's say you've got a turbine room, one turbine is going to be coming out, you need to bring another one in. You don't need extreme accuracy. You just need to have a great idea of exactly what's there, what's coming in, so you can measure both of them, make sure it's going to fit. Underground transport, anything underground, the Hovermap is going to excel at. That's our bread and butter right there. Urban mapping portions, I'm excited to show you this next slide because it's the coolest you're going to see. Bridge inspection, there's a ton of money, as you were showing earlier, for infrastructure in the US. All the bridges need to be scanned, and there's money for it. So with a Hovermap, what a lot of agencies are using it for right now is put it on a drone. They don't need full autonomy. They just want that collision avoidance. So they use a pilot assist, and they'll send it out one side of the bridge. go underneath it, scan, hit the other side. It's all visual line of sight, so they really never lose contact with it and come back. The benefit of this is if you're doing it the traditional method, probably have to shut the bridge down because you need to be on top of it. This way, you're not flying over the top of the bridge. You don't have to shut anything down. 10 minutes, hit both sides underneath, come back, you're done. With the STX, because it has a triple return, it's much better for terrain mapping. The returns actually get through the canopy very nicely. So you're going to get to the ground with some of those lasers. And as long as you have a good ratio of lasers hitting the ground, you'll be able to remove that canopy in third-party software and get a good topo. Telecommunication towers, anything that is hard to scan, and then anything indoors is going to be ideal for us.
You have a question?
You
You want to ask it now?
Complex environments where there's a lot of just random things out there, pilings, furniture, or anything. We're going to be able to pick that up. You can use third-party software to wipe a lot of it out, but the time it takes to get in there, do small buildings is incrementally faster than anything else out there.
We have a question on this side.
Yes.
Really more of a comment on the previous slide at that scan of the jetliner.
Yes.
Did you catch the two missing bolts?
They were on the inside of the door, so we didn't catch that. Yeah. That's a Boeing joke. And then urban mapping, large areas. I think this next slide is the one. Yeah. So this was a 30-minute walk downtown New York, the Hovermap STX. So they had it on a backpack. All they did is walk down Manhattan or whatever street this was. We're viewing it in intensity mode. So intensity, you're picking up the reflectivity nature of the objects around there. But you can see just how far off the side of the buildings we're getting with this, with that 300-meter range from the ground. So the capabilities of the STX as compared to the ST, there's definitely use cases for both. But anything where you have just a longer distance you need to work with, like over at Kennecott, you got a little bit of a mine over there, and that's a pretty big area to scan, and would be a good solution for them to continue using it like that.
What did you use to create this fly through?
I think my team, so we can do it in Aura. I think at this point they use Cloud Compare though. Yeah, and it's cost effective. Yeah. So here's another example of what we can do, just scanning a bridge. So we mounted the spot, walked across a bridge, and came back. So from here, it's downtown Brisbane. You can see that all the way across, we caught the other bridge, a little bit of it off the side of the buildings here. But from this, we just get these absolutely incredible data sets. Substation work, understand that there's a little bit of a setback there. They're very complex, a lot of wires, a lot of just infrastructure going on in there. With the Hovermap, you can walk it or fly it and still get this type of result, but you don't need to be real close. So you can get a setback of 50 meters and still get this type of result. Transmission lines are great for us too. With the STX, that added accuracy. We can measure tree setbacks. You can understand, the size measurements of everything on there and understand the line droop. We all know what dams are, kind of understand what we did here. But just a quick flight, maybe 10 minutes from one side to the other, over the top and back, and we were able to capture all of this. Just some of the other cool work that we've done. That's me at Bingham. Rio Tinto is one of our users with Monson. Underground use, there's really no place where we haven't found a good use case at this point. So Stopes is probably the number one use case that we have because it's just so effective. You can't get people in there. And using a CMS takes a long time. They're expensive. We're replacing CMS left and right now because it's much more effective, cost effective, and the time it takes is maybe 3 minutes to do this instead of, I don't know how long CMS is taking, but I know that they're quite a bit longer than that. We can do draw points. We're working on convergence monitoring with Aurora right now. We've got several beta testers at some of the coolest mines like Kid Creek and others who are testing it. And so far, looks like we're probably going to launch convergence monitoring in March within our software.
We have a comment that CMS of a slope takes about 45 minutes with setup.
45 minutes with setup. Yeah. And we do have a CMS adapter, so you can use the exact same pole equipment that you have. Just replace that old unit when it goes bad, throw the Hovermap on there.
We have another question to Aaron. Can issues with the FAA be avoided with low-level flight near airports?
So it's hard, depending on how close you are to the airport. They sometimes will give you waivers and sometimes will not. They're a little bit picky about that. Where we're based in Denver, we're right next to this Centennial Air Park. We can't fly out of our offices. We got to drive about 20 minutes.
Yeah.
A really long pole and walk around.
There you go.
Or
Don't
handheld?
try to get your note of approval, basically, is what he's saying. Don't just assume you're good if you're staying low elevation.
Yeah.
Low altitude.
Yeah, they'll set the elevation for you. You know, if you're below 50 feet or 100
Yeah.
feet, you shouldn't be an
But do your
issue.
diligence, no matter what. And
Yeah. You don't want to make enemies with the FAA.
Probably not.
Hey, Aaron, while we're going on these questions, earlier somebody asked if the Hovermap produces survey grade data that could be used for design purposes.
So survey grade is a word that gets thrown around there a lot, right? Because you guys know what survey grade is. We understand survey grade. We're going to be 5 mm accuracy in closer areas, you know, up to 15 mm accuracy in large areas such as above ground, you know, doing the bridges, probably if you're closer, better than that. I like to stay away from the term survey grade. What I like to think is if you don't need a total station out there, if you don't need that extreme accuracy, the Hovermap is going to work. So if you look at, you know, and we talk to people all the time, you know, what type of level accuracy do you need? They say survey grade. Okay, well, tell me what survey grade is to you. I'm like, well, you know, 1/4 inch. Well, not really survey grade, but we can certainly do that all day long.
1/4 inch. Pretty good.
Any other questions there?
No.
Nope, that was it.
Yeah,
Thank you.
Thanks for letting us interrupt you.
Sure, sure. So with our cage, shaft scanning is very quick, very easy and safe. Tether the cage, drop it down. This is a mine, a petro diamond mine in South Africa. And essentially what they wanted to do is understand overbreak, underbreak. So with that, they can do change detection over time, scan it multiple times every day if they want to, every week, every month, and get an idea of where the changes are taking place. So this is a typical flight when we're doing stope mapping. Essentially, you take off, pilot sets back, take off the barricade, fly it out. When you get a little bit closer, just set the waypoints once you can see, or even if you don't know what's out there, you can set them. But set waypoint 1, set waypoint 2, automatically goes down, comes back up, does all the work for you. Safety is key in mind. This is a good example of what we're able to do with tracking those changes within the mining. So with the data, I mean, you guys can do with it whatever you want after the scan is done. Again, LAS, LAZ, EOY, E57, something like this. They wanted to renovate a office building, so they needed a good scan of it. Didn't have to be, didn't need a team out there to do it. 50 minutes inside, walk around for 15 minutes outside. And from that, they're able to take it, do a full as-built with it, and have that TrueCAD data and design the future office site based on that. Bridge inspection, it really is the fastest growing part of our business right now because the effectiveness and time it takes to do it is just takes no time at all. This was a 15-minute flight and they flew either side, flew underneath, never flew over the top of it. And from that, they were able to get these Revit structural drawings and something like this, from point A to point Z, probably an hour. Another kind of a unique one is we have a magnetic mount that can be used on vehicles or anything metallic. We just attached the magnetic mount to this elevator, dropped it down, came back up, and had this output pretty quickly. Yes, sir.
So you're probably biased, but how would you compare this to the Leica BLK 360?
BLK
Will you
360.
repeat the question?
Yeah, we need
Just in case,
the-
like,
He asked, how does it compare to the BLK 360? So they've got good software. Their 360 camera is pretty good. We're still working to get better at our 360, and it's moving fast because we're going to be able to actually colorize with the 360 camera here soon, colorize a point cloud or do the 360 imaging separate. The XT32, the point cloud density is going to be much better. The SLAM algorithm that we're using is called Wildcat. Like GeoSLAM, pretty much all of the Chinese manufacturers out there, they're using what is called CT SLAM, which was the original SLAM algorithm developed by CSIRO. They stopped developing that when they came out with Wildcat. The reason they're all using it is because that SLAM algorithm is free. We pay a ton of money for the Wildcat, and they're continuing to improve it, which means the accuracy and the accuracy is better. The amount of slip that we see compared to them, even using the exact same puck, is much less. Just much better accuracy, much better precision as well.